Alright, so in the previous video we saw that where we're actually headed is this equation here. Let's erase it. It's this equation here, T1 plus the sum of all the work done by the forces is equal to T2. This is the principle of work and energy, and it involves these two terms here that are the kinetic energies of the particles, half mv squared, half mv2 squared, half mv1 squared, and this refers to all the work done, the sum of all the work done by all the forces acting on that particle. So like I said in the previous video, we're going to now focus for the next few videos on this second term to understand all the different types of work that we can get. Okay? So how is work defined? Well, if we consider a particle moving along this path, this curve, and we consider the particle, say, moving from that point to that point, then at this initial stage it has a position vector r, and at the second stage it has a position vector r prime. Okay? And so we know that the displacement dr is equal to the final position vector minus the initial position vector. Okay? So that's just how you define your displacement. And then what we see is that, I'll come back to this term here, what we see is that this differential work, du, by the way, it's a scalar, take note, is equal to the dot product between the force and the displacement vector. So there's the displacement vector, there's the direction of the force, the work done, and this is the differential work done here, is the dot product between these two vectors. Okay? And it's also this is in vector form on the right. In scalar form, it is equal to f ds cos theta. So f ds cos theta. These are the same. It's the magnitude of the one vector times the magnitude of the second vector times the cos of the angle between them. Just go and revise the dot product. So both of these are correct. So remember that these are two vectors, but it gives you a scalar. Okay. Now, so this is the definition of work. It is the force times the displacement times the angle, the cos of the angle between them. So what is this telling us? It is telling us that the work is only equal to the component of the force that's in the direction of the displacement, or it's the component of the displacement in the direction of the force. Okay, so that's what you need to take note of. So if you've got a force there and it's moving in that direction, then the work is only the component of the force that's in the same direction, or it is the component, work is the force, the component of the force in the same direction as the displacement times the displacement, or it's the displacement in the direction of the force times the force. It's the dot product. Okay? Alright. So now what does this mean? Now let's just take a look over here. If this angle between the force and the displacement is less than 90, between 0 and 90, then we will have positive work. Positive work. Okay? That means that the component of the force is in the same direction as the displacement. The second one is if this angle is greater than 90 and smaller than 180. Say now the force is there. Right, so this angle is over there. Then if you do the dot product, you're going to get a force that's acting in the component of that force will be in the opposite direction. So the dot product would then give us a negative work. Okay? So if you've got the force and the displacement in the same direction, you've got positive work. If you've got the force and displacement in opposite directions, you're going to have negative work. And what do you think is the third one? The third one is if your force and the displacement are perpendicular to each other, then you're going to have zero work. Perpendicular force and displacement gives us zero work. Okay, because the dot product is this. If cos is 90, we have 0. Okay, so I hope that you just pick up these concepts. Okay, and then the next few videos we will go more into detail of the different types of forces.